Basically, electron dot diagrams help us with electron configuration, and they focus on the valence electrons, which are the outermost electrons involved with bonding. Nitrogen has an atomic number of 7, atomic mass of 14. If we draw the electron configuration, we have 1s2, we have 2s2, and then there are 3 2p sublevels, and they will each have 1 electron. And just to keep the spatial arrangement, we can call this X, Y, and Z. The electron dot diagram is only going to focus on the highest energy level. So here's 1s, that's the first energy level, row 1. That's not part of this electron dot. Only energy level 2. And it's only going to focus on the orbitals that are involved in bonding, and that is the s and the p orbitals. Let's look at a couple basics. First of all, you can see the difference between an orbital with a pair of electrons and orbitals that are unpaired, because energetically there is a difference. When we do the nuclear symbol, like this, and then we write out the electron configuration, what you're going to notice is there's 2 different energy levels. We only want the highest energy level and the S and P's. Everything else is going to be left out. It's actually called the kernel of the atom. So this right here is part of the structure, but it's not going to be drawn. We call that the kernel. That represents all the protons, neutrons, and electrons that are not in the valence, because actually valence is only the outermost electrons. So let's look at a general formula for drawing electron dot diagrams. If we have any element, we'll call it element X. The outermost s and p orbitals are what we're interested in. And it doesn't matter what energy level you're at, as long as you're beyond energy level 1, because that only has 1 s. As soon as you get to energy level 2, 3, 4, 5, 6, 7, you have s and p's there. We designate the s to the right, and it doesn't really matter where you put it. We're just making a convention here. Whether it's 2s, 3s, 4s, and so forth, there's only 1s sublevel. There are 3 orbitals for p, however, so we would put one here, like px, py, and pz. If it's energy level 2, this would be 2s, 2p, 2p, 2p. If it's energy level 3, 3s, 3p, 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 and so forth. Only use those highest energy levels. Start with energy level 1. We have hydrogen. You notice there's only 1 proton, therefore if it's neutral, it'll have 1 electron. There will be 1 dot, and that would be the 1s1. If we drew it, it would look like this. Second would be helium. Has 2 protons, therefore 2 electrons when it's neutral. There's the 2 electrons, and it would be in the 1s energy level and sublevel. And there's 2 electrons here, 1 there. Therefore, there's going to be 2 dots in the s, so we put it right there. And that would be energy level 1. Energy level 2 begins with lithium, and lithium would have to be 1s2, and then 2s1. There's 1 left. There's 3 electrons there. So we would draw it like this. Just 1 dot. Notice this is n equals 2. Second energy level. And if we did beryllium, which is the next one, beryllium would actually look like this. You could continue this by going 1s2 and 2s2. Notice the 2 dots. If we look at boron, there's 5 protons, therefore 5 electrons in a neutral atom. We don't care about the first energy level, we only care about the highest energy level, which is energy level 2. We wouldn't even need this here. We're only focusing on this, and you know there's just 3 electrons. The first 2 go in the s orbital, and then there's 1 p electron. If we look at chlorine, chlorine has 17 electrons because it's a neutral atom and there's 17 protons. Here's the electron configuration of chlorine. 1s2, 2s2, 2p. We don't need any of this. All of this would be called the kernel of the atom. It would include the protons, and it would include all those electrons up to the outermost electrons, which are the 3s, 3p. How would we write this? We'd have chlorine, we'd put the first 2s electrons right here. That's these. And then the p electrons we'd put in the same way we would the electron configuration using Hund's rule. We have 5 more electrons. There'd be 1 there, then 1 here, and then 1 here. And then you add the second electron to whatever one you pick. I'll pick these 2 here. This one's open. That's what's going to bond right there. And that's chlorine. It's the 3rd energy level. So you can see the electron dot works at any energy level. You have to use the highest energy level S and P's. If we take a kind of different angle at it, here's a table of electron configurations for all the elements on the periodic table. And let's begin with elements 1 through 36. You notice the energy levels are going to be shown, and that's right here, energy level 1, energy level 2, 3, and 4. And then the sublevels that are involved are also there. So hydrogen and helium, there's your 1s and electrons right there. So there'd be 1 dot and there'd be 2 dots. Then if we go to energy level 2 with lithium, beryllium, all the way down to neon, here's the 1s electrons all the way down. That's part of the kernel. But then you go to the second energy level 2, so 2s electrons are here all the way down. But then you have 2p electrons as well. So when you come to dots, you'd have 1 dot, 2 dots, 3 dots, 4 dots, 5, 6, 7, and 8 dots, and that's the maximum. Go to energy level 3, it's sodium all the way down to argon, same thing. Now energy level 1 and 2 become part of the kernel, and it does include the protons and the neutrons, but not the outermost electrons. You start with sodium, it has 1 3s electron, so 1 dot. This would have 2 dots, and then you get the 3s and the 3p. 3 dots, 4 dots, 5 dots, 6 dots, 7, and 8 dots again. And you can continue to do this throughout the entire periodic table. You'll notice here that potassium and calcium jump to the 4s, 1 dot and 2 dots. Let's jump to the 5th row on the periodic table. You notice here it's got 3p, 3d, 4s, 4p, all the way up through. This one has a 5s as its highest, rubidium has a 5s electron. That means it would only have 1 dot. Even though you have all this other stuff, these are part of the kernel. Cesium has a 6s electron. All the previous, below that, 5, 4, 3, 2, 1 energy levels are not included in the electron dot. They're not the valence, only the outermost S and Ps.